All right. So this is the plan. And it's a big breakout session, and so we can just play it by ear. But I thought probably the best thing would be for me to give an introduction to the structure of the container ontology, and then and maybe and the container server, and then so I'll do a pretty short presentation here, and then I thought we could move on to one of the collab spreadsheets where I show how you can interact with the server, and then after that we could move on to actually working very much inside the ontology, either poking around inside it and working on expanding it, working with enhancing the container API, if that's interesting. One of the things I did was also collect up what I did to translate Stratios's catalog of microplates into the OWL format for use in the container ontology. And I think it would be possible to use that as the starting point for translating the OpenTrons labware catalog, if we're interested in doing that as kind of a project. Okay, so and then yeah, these are my assumptions, is that this is kind of the focus and what people will be interested in. And definitely, since I'm a computer scientist and not a lab biologist, everybody's going to know more than me about what should be in here. So I'm kind of facilitating getting it in there and making it usable. But if you see something that looks wrong to you, it probably is wrong. And we should just probably fix it. Okay. So just a quick background about how the ontology works. And the reason that this is here is that in a few minutes, I'm going to tell you things that are not normal about this, that you will need to know to understand how things work. But the normal stuff is that, we have classes, the classes have subclasses. OWL jargon, for whatever reason, uses the term individual instead of instances. And something that you need to know about how the container ontology works is that the individuals in the ontology aren't individual containers in the world. Instead, the individuals really correspond to catalog entries. And basically the reason that it is that way is that we need a way to tell when you look something up, when you've found enough information about a container. So when you've really gotten down to something you could order or, pull out of inventory. And if everything was classes all the way down, it would be very hard to know when your lookup is done. So here, you can sort of think of the individuals as, the individuals are really catalog entries, or if you want to think of them that way, they're like prototypes. So in PAML, you'll mostly want to point to one of these things rather than, you know, you won't want an instance of these things. Okay. Instances have, you know, just like in most schemes, instances have properties. A slightly oddball thing is that properties, there are two kinds of properties in OWL. One is a property that has an object as a value, and the other is a property that has a primitive data item like a string or a number. And that's just a constraint that comes from the way OWL is sort of fielded on the web, and also about just how the reasoner works. So you have to keep that in mind. And then again, just like in any class system, the class can have express constraints on what the property values can be. All right, so here's the big picture right now, and this was taken out of the Protégé editor. This is the big picture of the microplate bit of the container ontology, which is really the only part that's been built out at all. Okay, so I guess the key things that you need to know is that, you know, we've introduced classes for particular subtypes of plate that we need to talk about a lot, like the standard 96, 3084, and 1536 wells. And then we have some classes for the slash standards. For reasons which we could go into later, but for the moment, really the /4 standard is the only one that we could make much effective use of. And this one is the one that specifies how a micro plate well is going to have the wells laid out and labeled. So you can say that you have a /96 well plate, and that means you know how to index it. So that's why that's there. And we have some, you know, because we wanted an easy way to refer to some things in protocols. We have, you know, opaque plates and clear plates, but those are just convenience classes. Okay. And then there are a bunch of properties used in the ontology. And Brian's talked already about how some of these things are inadequate and we need to expand these sets. I don't know, let's just skim down here through, and you can see the ones that are mostly used are available at. So you can have a lab, and you can say that you know, you can say that you can assert that something is available at that lab, like available at Stratios or something. The instances will have catalog entries, maybe more than one. So you can say, you know, who's the vendor, what's their catalog number. Let's see. We have some geometric properties which we can make effective use primarily for cases where I've been able to find a data sheet, but for some of these plates, I just haven't been able to populate this stuff. Oh, and we have colors, and one of the critical ones is the bottom shape for the wells. So those are some object valued properties. The data properties are similar. So we have catalog, if we have a catalog entry, well, that catalog entry will have a catalog number. Colors have color names. We have the row and well counts. Some of these are the numerical value is something for when we'd use measurements. And then we have lab names and vendor names that we can. So we have vendors that are sort of unique things, and you can refer to them by one or more vendor names to look them up, and that supports having a canonical representation for the vendors. Okay, so okay, so now if you want to make effective use of this, there are some unusual things about OWL that you need to know. And because it's not necessarily my favorite thing that OWL uses lots of terms that you're familiar with from other contexts like class and property and things like that, but it uses them often in ways that don't agree with what you're used to as far as meaning goes. And I tried to pull out here some of the key differences. So first of all, some classes have definitions, right? So what we're saying here is a slash for 96 well plate is defined as a microplate that has 12 columns, 8 rows, and 96 well count. Why does that matter? The reason it matters is that an OWL reasoner will use definitions to automatically classify instances and classes. So for example, if I bang out a description of a new instance and I say, well, it's a plate and it has, this well depth and 12 columns and 8 rows, and then the OWL reasoner will, I don't have to tell it that it's a slash 96 well plate. The reasoner will figure that out itself. And the advantage of that is that later on, when I say I need a slash 96 well plate, the reasoner is able to find all the things that satisfy that description. So what that really means is when you're defining a class, you have to think about what it's equivalent to and also what properties it has. So for example, here we just assert that a slash 96 well plate is a slash plate, right? It's a plate that complies with this standard. Okay, so there are things that we just assert about it, but then there are also things that the system will infer. Like here, it infers that this is a 96 well plate. I didn't have to assert that for it. And then another thing that's unusual is multiple inheritance is normal. Okay, it's a normal thing to do. So for example, here we have a clear 96 well plate, and that's defined as a plate that's clear and that is a / 96 well plate. Okay, so that's just a normal thing to do, because what OWL is sort of for is to classify things, and you want to classify on multiple dimensions. A single, if you wanted to do this kind of reasoning, just single inheritance doesn't really work for you. And notice, one last thing I should say is that the clear plate here, that's just a convenience. I could have written, that has value color clear instead of clear plate, because that's just the definition of clear plate. It's a plate that is clear. Okay, so we can do that equally well. All right. Okay, so so again, what's the point? What's the point? The point is that we can ask the OWL reasoner to tell you what well plates, 96 standard 96 well plates it knows about. Right. And again, this is using the protege editor, but if you're working with PAML, presumably you'd be, querying the server for this information instead. And we can make compound queries, right? Again, the clear 96 well plate. And down here at the bottom, we can say, I need a clear 96 well plate that's available at Stratios, right? So I can express that kind of query in this sort of unusual syntax, where I can say, that I want a thing that has the available at property with the value Stratios. Okay, that's just the syntax that's used here. So that's really my introduction to the ontology.